Hi there, Mr. Sutton bringing you the AB Calculus 5-1 classwork answers on basic antiderivatives. On this problem, we're eventually going to use the reverse power rule, but first we need to express this as an exponent. So I can rewrite this as 10 times x to the negative 1/2. And then using my reverse power rule, this is going to bump up to a 1/2, multiply by the reciprocal of 1/2, so multiply by 2, and we end up with 20 x to the 1/2 plus c. For this problem, we're first going to express this as an exponent, and then we'll use the reverse power rule. This can be written as 4/3 times x to the 1/3. 1/3 bumps up to 4/3, and then if we multiply by the reciprocal 3/4, that's going to cancel out the 4/3 over here, and we just end up with x to the 4/3 plus c. For this problem, we're taking the antiderivative of cosecant x, cotan x dx. Now, this is almost going to be cosecant x plus c, but if you take the derivative of cosecant, you actually end up with negative version of this. So to go backwards, we have to make the original negative, so this will end up being negative cosecant x plus c. For this problem, we want the antiderivative of cosine of x dx. This is the thing that I have to differentiate to get cosine. That's going to be sine of x plus c. On this problem, we're going to use the reverse power rule. This is x to the 1. That bumps up to a 2. And then we're multiplying by the reciprocal of that by 1/2. So this will end up being 1/4 x to the 2nd plus c. On this problem, we want the antiderivative of negative 1/3 secant tan. Now, when you're doing trig functions, anything that antidifferentiates to a c function is going to be negative. This antidifferentiates to secant, so it's going to keep its sign. This is going to just be negative 1/3 secant t plus c. For this problem, we're going to rewrite this with a exponent and then use the reverse power rule. So this is really just 4 times z to the negative 1/2. That bumps up to a positive 1/2, and we're multiplying by the reciprocal of 1/2, which is 2. So then we get 8z to the positive 1/2 plus c. On this problem, we want the antiderivative of cosecant squared of x dx. This is going to antidifferentiate to a cotan x, but when you antidifferentiate to a trig function that starts with the letter c, it's always the opposite sign that you started with. So this ends up being negative cotan of x plus c. On this problem, we have a few steps to do when we're antidifferentiating this expression. This 5 is going to become 5x because the derivative of 5x is 5. And then for the 1 over x, that's going to be minus ln of absolute value of x plus c. For this problem, we're antidifferentiating a polynomial, so we're just going to go term by term and use our reverse power rule. For the first one, this bumps up to a 3, and we're dividing by 3, so 1/3 x to the 3rd. This one, this exponent bumps up to a 2, dividing by 2, that's going to be negative 2x squared. And then this one is just going to be plus 7x. And then we have the plus c that we don't want to forget about at the end. On this problem, we're going to use the ln rule. This is kind of like having negative 4 times 1 over x. So that's just going to be negative 4 times ln of absolute value of x plus c. For this problem, we've essentially got 2/9 times 1 over the square root of 1 minus x squared. 1 over square root of 1 minus x squared, the antiderivative of that is going to be arcsine. So this is just going to be 2/9 times arcsine of x plus c. For this problem, we're going to go term by term and use the reverse power rule. For the first one, this exponent bumps up to a positive 1/2. Multiplying by the reciprocal of that by 2, we have 8x to the 1/2. For the next one, this exponent bumps up to 3/2, so we're multiplying by its reciprocal 2/3. That's going to be 4/3 x to the 3/2. And then over here, this bumps up to a, let's see, a negative 3/2. So we're multiplying by the reciprocal of negative 2/3, and we have x to the negative 3/2, and then a plus c. On this problem, we want the antiderivative of negative sine of x. What do I have to differentiate to get this? Oh, that would just be positive cosine. Derivative of cosine is negative sine. So we then end up with cosine of x plus c. On this problem, I'm going to use my reverse power rule. This exponent bumps up to the 4th power. Dividing by 4, we have 1/9 x to the 4th plus c. For this problem, we've essentially just got 1 over x times dx. So this is just going to be an antiderivative of ln of absolute value of x plus c. For this problem, we've essentially got 8 times 1 over 1 plus x squared. Antiderivative of 1 over 1 plus x squared, that's going to be arctan. So this is just 8 times arctan plus c. On this problem, we can use our reverse power rule. This bumps up to an exponent of 2. Dividing by 2, we just end up with x squared plus c. For this problem, I'm going to rewrite this with an exponent and use my reverse power rule. This is x to the negative 1/2. That bumps up to a positive 1/2. Multiplying by the reciprocal of 2, I end up with 2x to the 1/2 plus c. On this problem, I'm going to use my reverse power rule. This bumps up to an exponent of 3. Dividing by that, we've got 2/3 x to the 3rd plus c. On this problem, I'm just going to go term by term and use the reverse power rule. This first one bumps up to an exponent of 3, so we've got 1/3 x to the 3rd, and then plus 3x plus c. For this problem, I'm going to use my reverse power rule. This bumps up to an exponent of 7/5, adding 1 to that, and then we multiply by the reciprocal of 5/7, so we have 5/7 x to the 7/5 plus c. For this problem, which of the following is an equation of a curve that intersects at right angles? Every curve of the family y equals 1 over x plus k, where k takes on all real numbers. So the key on this one is that we need to intersect at right angles. That means that the curve that we're looking for is perpendicular to this curve. What that means is that the slopes of our two curves have to be opposite reciprocals. So let's start by finding the slope in general at every value k for this curve, and then we'll take the opposite reciprocal of that. So this is really x to the negative 1. The derivative of that's going to be negative x to the negative 2, or negative 1 over x squared, if we write that as a fraction. The opposite reciprocal of that is going to be positive x squared over 1, or just positive x squared. So now we need to find a curve whose derivative is x squared. Basically, we're asking for the antiderivative of x squared. So g of x, then, the antiderivative of x squared, is going to be, using our reverse power rule, this is going to be an exponent of 3. Dividing by 3, we have 1/3 x cubed. And we can write a plus c there, but they didn't write it in any of the equations here. However, the only answer that has a 1/3 x cubed is going to be choice D, so that's the one we're going with. For this problem, we want the antiderivative of secant squared of x dx. So this here is the derivative of tan of x. So tan of x plus c then would be our answer, choice A. For this problem, we want the antiderivative of 3 secant squared of x plus 2. Going term by term, this is going to be 3 tan of x plus 2x plus c. So that's going to give us answer choice B. On this problem, we want the antiderivative of e to the x plus e dx. So going term by term, e to the x is its own derivative, therefore it's also its own antiderivative. So we have e to the x plus, this e is just a constant, so its antiderivative will just be e times x. And then we have the plus c, of course, at the end of all of these. So that ends up giving us answer choice C, E, actually, ironically, E. For this problem, we want the antiderivative of 1 over t times the square root of t. To make my life easier, I'm going to rewrite this using an exponent. So this is really 1 over, let's see, t times t to the 1/2. That's going to be t to the 3/2 down there. So overall, we can write this as t to the negative 3/2 if we bring that upstairs. Using my reverse power rule now, this bumps up to the negative 1/2, and then I have to multiply by the reciprocal of that, which is negative 2. So I have negative 2 times t to the negative 1/2 plus c, and that actually gives me answer choice A. They already gave us one.